you guys had said that if you saw something like this, you'd be able to do it. So it's all this stuff being raised to the -4 power. So once again, all this stuff being raised to the -4 power here. So we have -3 to the -4th power, x to the 1 times -4. Raise a power to a power and you multiply. 1 times -4 is -4, and then -3/4 times -4 is 3, right? Very good. Yeah, so you're right, absolutely. It's -12 or +12 over 4, which is a great way, exactly what you did. And then that divided by 4 is 3. From there, we flip negative exponents. Anything with a negative exponent. So we draw our line. This has a negative exponent, so we flip it over a fraction. Negative exponent, we flip it over a fraction. So on top, we have a y cubed. On bottom, we have -3 to the +4th power, because we flipped it, it's now a positive exponent. And then x to the +4. So then from there, if you have a number, you'll calculate it. So, what's -3 to the 4th power? Make sure you type it in parentheses, everybody. -3 raised to the 4th power. 81, positive 81. So on top, we have y cubed. On bottom, we have 81x to the 4th. How many of you got 100% correct? Couple of people. Okay, guys, we need to get better at properties of exponents. I'm telling you, my secondary 2 students, they get that right. You guys, so we have to really get better at these. So we'll keep practicing them through the year. What are you having issues with so I can help you out?
I just forgot to put something out. Yeah, I didn't something but I wrote negative.
Okay, so just all this sign there. So that's not a bad thing. Now you know. Yeah.
I felt like you raised like the exponent to the -4. So I went like -3/4 to the -4th power.
Oh yeah. Okay, so our some good questions. So raise a power to a power and we multiply. So you get we're multiplying them, right? So just a little error. Okay, any questions on this problem? Guys, we've got to get better at this stuff. Okay. Okay, let's get to what we're doing today. So today we're going to graph absolute value functions. Luckily, if you've been in my class, you've already graphed it. In Waltcott's, have you graphed absolute value functions? Yeah. Okay, awesome. So today's kind of a review day. We need to keep going back and reviewing these things. So we're just going to kind of look at it differently since we were just talking about taking functions, families of functions. We know that if you have a negative in front, it flips it over the x-axis. It's a reflection over the x. We learned that it can stretch and compress. If a is greater than 1, it's a stretch. If a is less than 1, it's a compression. So keep that in mind. So remember, absolute value functions can just be represented as xy tables, and it can be represented as a graph. So we're going to be graphing these. Remember, absolute value functions are sharp V's, right? Everybody? Sharp V's? Okay, so absolute value functions, they do have an axis of symmetry. So before I wasn't making us write in the axis of symmetry and the vertex, but today we're going to. So axis of symmetry means the axis, the x value, where our absolute value function is symmetric across it. So once again, if I took this and folded it over that dotted line, do you see how it would be symmetric on both sides? All right. Now also notice always our x values, when they're positive, we're going to get an output of positive. If we get an x value that's negative, we're still going to get an output which is positive. So that's where the absolute value function comes in. That's what creates that. So if you plug in a negative into the absolute value, doesn't it come out positive? So do you understand that if you plug in a negative, it comes out positive? If you plug in a positive, it comes out positive. So that's just how absolute value functions work. Okay, so looking at this, we're going to be looking at shifted absolute value graphs, and stretched and compressed and reflected. So it says, what is the graph of the function y equals the absolute value of x plus 2? How is the graph different from the parent function? So our parent function is y equals the absolute value of x. That's the most basic non-shifted function. So my question is this 2 being added inside the parentheses? No, it's being added on the outside. So what does that do to our function? Shift it up or down, right? Does our sign stay the same? With added up on the outside, with our shift up and down, the sign stays the same. So it's shifting our function. So it's a shift up 2 units. Does everybody understand that? Questions? So that's how it's different from the parent function. So then, what is the difference between that and y equals the absolute value of x plus 2? That's our shift. It's added on the inside of the absolute values, right? It's added with x, so that's our shift Left or right, and we always go the opposite. So this one would be shifted left, left 2. So if we were to graph each of these, once again, I'm just going to do a really rough sketch here. This one would be an absolute value shifted up 2 units. So that would be like this. This would be left 2 units. So it would be back 2. So does everybody see the difference between the two? So you got to pay attention to that. Okay, so it says, this is my question for you. I want you to think about this. Do transformations of the form y equals the absolute value of x plus k affect the axis of symmetry? So I want you to think about that. Does the shift up and down affect the axis of symmetry? So ready, set, go. Think, talk to your group. Go. Yes or no? How many of you say yes? Every group should have a vote. How many of you say it does affect the axis of symmetry? Yes. How many say no? Okay, awesome. You're absolutely right. So good. Why do you say no?
It has to move left or right to affect the axis of symmetry.
Okay, so it has to move left or right to affect the axis of symmetry. So if we move it up here, is my axis of symmetry the exact same? If I move it down here, is my axis of symmetry the same?
Yes.
So anything added on the outside does not affect our axis of symmetry. Very good. Okay, so which of the following functions is the graph of y equals the absolute value of x plus 2 plus 3? Go. Decide with your group. Okay, what answer did you come up with?
D.
D. You came up with D. So if I was to mark this would be my answer. Okay, let's see. We always look at our shift first, left and right, and we go the opposite. So we're going left 2. So we're going left 2, and then this is our shift up and down. Added on the outside is our function, shifting our function up and down, and our sign stays the same. So left 2, up 3, that would be looking at this, D. Very good. Any questions? So we're pretty basic today. Okay, so now understand something. If you have an A value, something multiplied to your function in front, that's going to either stretch or compress it. Now understand, you always look at the absolute value or like the positive answer to see if it's a stretch or compression. Because if there's a negative in front, guys, it simply flips it over the x-axis. So it flips our, not parabola, it flips our absolute value upside down if you have a negative. But the slope will stay the same. So looking at this, guys, we have 3 times the absolute value of x. Is that a stretch or compression? If A is greater than 1, it's a stretch. So it's going to be more like this. Good. And then, once again, looking over here at this one. Is it a stretch or compression? It's a stretch still, right? We look at positive 3, right? And then that negative simply flips it over the x-axis. So the negative wouldn't be less than 1, right? We don't look at that. That negative flips it. Okay, good. So this one's still a stretch of 3. Now don't let that trick you. So once again, if you look at these, they're the same graph. It's just this one is flipped over the x-axis because of that negative in front. Okay, so let's just graph these. It says, what's the vertex and the axis of symmetry? And then graph. So I'm going to graph it first and then determine the vertex and axis of symmetry. So we're going left 6, up or down 0, right? So I go back 6, boom, there's my vertex. So my vertex is at negative 6, comma 0. So there's my vertex. And my axis of symmetry, isn't it going to be on that x point? So axis of symmetry, it would be x is equal to, what x value is that? Negative 6. There's my axis of symmetry. So it's going to be symmetric around that line. So then from there, we'll just graph our slope, which is 3. So we go up 1, 2, 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1. Same on the other side, 1, 2, 3 over 1. Or we could just say it's symmetric across this line axis of symmetry. So 1, 2, 1, 2. However you want to do it. 1, 2, 3 over 1. And then you draw in your nice sharp V. I didn't connect that dot very good. Pretty easy, right? Same thing here. So we're going right 2. We're shifting it right 2 and down 6. And then our slope is 1/3. So it's a compression of 1/3. So just keep that in mind. So right 2, down 6. So our vertex is at positive 2, comma, negative 6. And our axis of symmetry is the x value. So x is equal to 2. And then we would do our slope, which is 1/3. So you go up 1 over 1, 2, 3, of 1 over 1, 2, 3. So same on this side, of 1 over 1, 2, 3, of 1 over 1, 2, 3, of 1 over 1, 2, 3, of 1 over 1, 2, 3. Now look, guys. This time our A value 3 was greater than 1. So it stretched our absolute value like this, a little bit skinnier. Now look, our A value 1/3 was less than 1. So it compressed it, meaning it smooshed it down. It compressed it down. Does everybody see how this is working here? We're all good. Okay, I think you guys are good. So now, what I'm going to have you do is do the whole front page. Now, I need you to graph these exact. So, there's graphing paper on your desk. Number the problem you're doing. So, today I need you to graph these exact. Ready, set, go. Do the front page. If you have something like the absolute value of 5x, for example, well, you could split it up. That's just 5 times x. That's actually the same thing as the absolute value of 5 times the absolute value of x. So that's just 5 absolute value of x. You see how it's the same thing? So let's say we have the absolute value of negative 3x. Well, that's the same thing as the absolute value of negative 3 times the absolute value of x. So that's the same thing as 3 absolute value of x. Well, the outside, we don't need to do anything with it. It's our, right? It's already our...
It's not in the negative. It's like 5x one. Yeah.
Then this would have been negative. Because the negative is not in the absolute values, right? So you just pull. So if it was like this, it's not in the absolute values, so it would have been like this. Few problems with you on the worksheet. So everybody, let's go to number 15. So now what you're going to have to get good at on this level, you're going to have to get good at rewriting these absolute value functions in a better way so that you can graph it much easier. So you got to take it, manipulate it correctly so that you're writing it in a way that's easier for you to graph. So let's look at this one, number 15. Y equals the absolute value of 3 minus x. I always like to put mine in like vertex form, kind of. So once again, I'm going to rewrite this. Isn't this the same thing as y is equal to the absolute value of negative x plus 3? Everybody, do you see how I'm manipulating it to my advantage?
Yes.
Now, if we have a negative in front here, if we have the negative in front of a variable and it's in the very front of our function, remember that we can always factor out negative 1, right? So we have the absolute value. I'm going to factor out negative 1 because this negative is in front, only if it's in front. So I'm factoring out negative 1. Let's write what's left inside the parentheses. Remember, when you factor something out, you technically divided each term by what you factored out. So negative x divided by negative 1. What's left right here? What's positive 3 divided by negative 1? Negative 3. So does everybody see how I just rewrote it like this? Now remember, we can split this up. Because these are being multiplied, this is being multiplied to this, what we technically have is the absolute value of negative 1 times by the absolute value of x minus 3. Do you see how I split it up? Well, why should I split it up? Because do you see how everything inside is taken to the absolute value? When I split it up, aren't they still all taken to the absolute value? Okay, so then what is the absolute value of negative 1? 1?
1.
So we have 1 times by the absolute value of x minus 3. So our final answer would be y is equal to the absolute value of x minus 3. Guys, this is equal to this. It's just, I manipulated it and rewritten it in a prettier form. Does that make sense, everybody? So we got to get good at rewriting these in a prettier form. Questions? Okay. Let's do number 20.
Wait, are we graphing these on another line?
These ones, I'm not going to have you, so guys, I know if you graph the whole front page, I know you know how to graph that, right? So as long as you can get it in a pretty form, I know you know how to graph it. So I'm just going to make you stop at writing it in the pretty form. Does that make sense? So let's do another one. You don't have to graph it, because I know you know how to graph it if it's in the pretty form. So as long as you get it to that part. So everybody, number 20. Once again, a little bit more advanced here. Y is equal to the absolute value of 3/4 x plus 1. Well, first of all, I don't want that 3/4 to be multiplied to x. So what I'm going to do, but you can't just pull out the 3/4 x, because there's that 1 there. Well, so what we're going to do is factor. So we have absolute value. I'm going to factor out 3/4. So then what's left inside? Now remember, if you factor something out, you divide each term by what you factored out. So I'm going to divide each term by 3/4. Does everybody see what I'm doing here? So 3/4 divided by 3/4 is just x. What's 1 divided by 3/4? Let's say you don't know. Take your calculator, type it in. 1 divided by parentheses 3/4. Hit enter, you get... Change it back to a fraction. 4/3. So we have x plus 4/3. Is everybody following me?
Yes.
So then we can rewrite this as the absolute value of 3/4 times by the absolute value of x plus 4/3. So then from there, we know the absolute value of 3/4 is just 3/4 times by the absolute value of x plus 4/3. Now isn't this written in a pretty form? Couldn't we graph that pretty easily? We'd be going left 4/3, right? Which is 1.3, and we would be going up or down 0, and then we would go up 3/4, up 3/4, up 3/4, right, everybody? Do I need to make you graph these? Would you know what you're doing?
Yes.
Do you see how in this form, though, it's much prettier than that form? We would know how to graph that. Okay. So, do the back page. Now, once again, on problems 15 through 23, you just need to write it in graphing form. You do not need to graph those. Just write it in graphing form. Have me check your answer in graphing form, because let's hope if you can write it in graphing form, you can graph it. Then I need you to finish the worksheet. The rest of the worksheet. So, major in this class. Any little error is really just a major error. Okay, looking at this, first of all, this is not in graphing form because we have something multiplied to x. So we've got to factor that out. Well, that's like a -1. So we have negative. This negative on the outside has nothing to do with the inside for right now. In this, we're factoring out -1. So then writing what's left in each term. Some of you are skipping steps instead of showing your work, and it's messing you up. So divide each term by -1. We have an x plus 2 left. Is everybody following me? If you would just do your steps instead of trying to skip, you wouldn't get them wrong. So please, just do it. All right, now we can split this up. We have a negative in front here. We have the absolute value of -1. We have times by the absolute value of x plus 2. Does everybody see how I'm splitting it up and actually showing my work so I don't make any errors?
Yes.
People who just skipped didn't get it right. What's the absolute value of -1? 1. Then we have times by the absolute value of x plus 2. And then don't we still have this negative in front? Yep, we do. So our final answer is y is equal to negative absolute value of x plus 2. A lot of you are forgetting that negative in front. In fact, I'm sure it's because you're not showing your work and making some errors. So make sure you're careful. Just show your work. Heavens to Betsy. It's a lot better to show your work and get it right than not and get it wrong.